Welcome back. We are in section or chapter 5.4, and we're going to talk about polynomial and rational inequalities. For the polynomials, I'm going to use the techniques that we just learned in section 5.3 to come up with, and actually 5.1, 5.2, and 5.3 to come up with this. And so basically what I want to know is when is the graph above the x-axis when it's positive, and when is the graph below the x-axis where it's negative. So for part A, I'm going to go ahead and move that to the other side. So x cubed minus 16x is bigger than 0. So we have to get it always with the 0 on one side. I'm going to go ahead and factor this. And so these are my my critical values. And we're going to use a skill that we already came up with to do this. We know -4, 0, 4. This is a third degree polynomial, and I'm going to pull this up from chapter 1. Notice the lead coefficient is positive and it's an odd. Positive lead coefficient and it's odd. It's going to start down and it's going to end up. And because everything's to the first power, we're not going to do any bouncing or anything like that. So here we go. So we're going to start down here. It's going to go up, down, back up, and up. And you can see we want to know when this graph is positive. So where is it positive? It's positive here and here. So how do we write that? Use interval notation. So notice there's no equal symbol here, so we're not going to include the -4 or the 0. So these are the conditions that x must meet. All right. Part B. Go down here, B. And everything's nicely factored for me already. Here we want to know when it's less than or equal to 0. Now, again, my critical values here are -3, -1, and 5. Now, this is once again a third degree polynomial with the lead coefficient positive. So again, I'm going to start down. It's going to come up, circle down here, and then back up. So we want to know when is it negative. It's negative down here and down here. Also, we are including the 0 in this case. So this is going to be -infinity to -3 in the bracket to show that we're including it. Remember, infinities always have parentheses. And then -1 to 5 inclusive. All right. Part C will come back up here. Part C, we're going to have to factor this ourselves. Squared plus 2x minus 8. And continuing factoring. And once again, we want to know when it's negative or equal to 0. And this is once again a third degree with a lead coefficient of that's positive. And so let's see here. We're going to have a -4, a 0, and a 2. So again, third degree positive lead coefficient. We're going to start down here. And again, we want negative. So negative is here and here. And inclusive. So -infinity to to -4, including union with 0 to 2. D, we have x to the 4th, and then x minus 3 less than 0. Now, the 4th power, what that's going to do for us is that's going to make it bounce. And you'll notice overall we have a 5th degree polynomial with a lead coefficient that's positive, which means just like the 3rd degree, we're going to start down and end up. And we have at 0 and we have at 3. So this one is going to do this. Blue again. So it's going to go here, but this time it's going to bounce off. And we want to know when it's negative, and actually at 0, because it's not included, we're going to have to skip that. So all of that is going to be the negative. So negative infinity to 0, skipping over 0 to 3. Not too bad. So the polynomials, not so bad. The rationals, a little more involved. Actually, a lot more involved. All right, so with the rational inequalities, it gets a bit more intense. We need to find our critical values. Actually, let's go through the list here. So move all the terms to one side, meaning we need a 0 over here. Combine all like terms in one fractional expression. That won't apply to the first one, but will for the second two. Factor the numerator and denominator, find the critical values, that's both numerator and denominator, and test the sign within each interval. This is going to be easier for me to just show you. So let's start with part A. So we have x plus 3 squared over x squared minus 4 is bigger than or equal to 0. All right. I'm going to factor the denominator. And what we're going to have to do is test several regions. So we're going to go here. Our critical values are both the ones that make the numerator and denominator equal to 0. We, of course, will never include 2 and -2. No matter what, that's not a possibility at all. So, but let's do, we have -3, -2. I know these aren't spaced right. And I'm going to siphon these off a little. And we have 4 regions to test. So what I'm going to do is I'm going to pick any value that's less than -3, then one that's in between here, one that's in between here, and then one that's bigger to see what the sign is. Unlike some of the polynomials, it doesn't, once you find one, it just alternates. It doesn't, these don't do that in the same way. So let's test a number back here. Let's test x equals -4. So -4 minus 2, -4 plus 2. That gives us -1 squared, -6 times -2. And that gives us 1 over 12. So we are positive here, which means any value of x I choose over here is going to make it positive. Let's pick 2.5 here. -2.5. 3 squared. I'm just going to actually do the subtraction. So -2.5 minus 2 is negative 4.5. Negative 2.5 plus 2 is negative 0.5. That numerator is going to be positive. I still have a negative times a negative. The point is, it makes it a positive value. And for this one, the space is so small. Let's just pick x equals 0. That's an easy one between there and there. When x is 0 there, I get 9. 0 there and 0 there are going to give me negative 2 times 2 is negative 4. And the point is here is that it's negative. Let's pick a really, really big number. So let's pick like x equals 1,000. Do you see that's going to make everything positive? So let's put 3 in there. 3 plus 3 squared over 3 minus 2, 3 plus 2. So that's 6 squared over 1 times 5. The point is, it's positive. So they want to know what values are going to make it positive. It's bigger than or equal to 0. So let's write our answer. That's going to be from negative infinity to negative 2, including negative 2, and then from 2 on. So this is negative infinity to negative 2, including negative 2. Oh, but we can't include negative 2 because that would make it in the denominator. So we definitely have to put a parenthesis there. Union with, and we can include 3. That's fine in the numerator. 2 and on, actually, but not including 2. Again, we'll be dividing by 0 here. So like I said, a little more involved. Let's do B way up here. This is B and C. So B, so 2x minus 1 over x plus 4 less than or equal to 2. So here we have a bit more of a problem. I have to have a 0 over there, so I'm going to subtract a 2 to both sides. So 2x minus 1 over x plus 4 minus 2 is less than or equal to 0. Now I have to get a common denominator now. So that's going to be 2x minus 1 minus 2 times x plus 4 all over x plus 4. Now we have to distribute, combine, and then figure out what our critical values are. And the 2x's are gone, so this is negative 9 over x plus 4. We have one critical value in this case. Awesome. That's going to be negative 4. We only have 2 regions to test. So let's pick x equals negative 5. So this is negative 9 over negative 5 plus 4, which is negative 9 over negative 1, which is 9. Everything here is positive. And let's test over here. We'll do x equals 0. That seems the easiest to me. That's going to give me negative 9 over 4, which is negative. And they want to know when it's negative. Now, we cannot include negative 4 because even though there's the equal symbol, because it's in the denominator, and we can't divide by 0. So our answer is going to be negative 4 to infinity. And for part C, use the back of the previous page. So here I have 2 over x minus 1 is bigger than 3 over x plus 2. Scooch that down. This one's even more involved because I still have to get the whole thing equal to 0. also means that I have to get a common denominator. So this is going to have to be x plus 2. This is going to be x plus 1, x plus 1, minus 1. So we'll get 2 times x plus 2 minus 3 times x minus 1 all over x plus 2 times x minus 1. So we get 0. And we have to distribute and combine, and then we can start the testing process. So let's see, it looks like we're going to have 7 minus x. So it looks like our critical values are going to be x equals -2, 1, 7. So let's make this nice and big. We have lots of space to write. So -2, 1, 7. We'll just test a value in each of these regions, each of these 4 regions. So let's test x equals -3. So 7 minus -3, be careful there. -3 plus 2, -3 minus 1. That's going to give me 10 over -1 times -4, which is 10 over 4. And it reduces, but who cares? We just want the sign, it's positive. But -2 and 1, I'm going to pick 0. X equals 0. So it's going to give me 7 over 2 times -1, which is -7/2. And again, the number is irrelevant. The sign is what's important. So between 1 and 7, let's do x equals 2. 7 minus 2 over 2 plus 2. 2 minus 1. 5 over 4 times 1 is positive. Anything bigger than 7, so let's pick 8. 8. 7 minus 8 over 8 plus 2. 8 minus 1. 1 over 10 times 7, which is 70. So the whole thing is going to be negative. They specifically want to know when things are positive, and we're not doing the equals. So positive is going to be -infinity to -2, union with 1, which we can't include. Well, we wouldn't anyway. 1 to 7. That's how you do it.